Hello. Okay, today in this video I'm going to go over a little bit about how to measure the volume of a bag of objects, because we're talking about trash. You know, our theme of sustainability relates to a lot to the subject of trash, and we're going to talk about the amount of trash that we collected along the sides of roads last year. We're going to use that trash data when we talk about a lot of different mathematical problems, because we'll use that trash data for a number of the different mathematical exercises that we're going to do. And so what we did last year when we collected trash is we wanted to see how much trash was there, and you can express the amount of trash that's there in any area by the mass of the trash. In other words, weight. You know, the weight of the trash and the weight of anything and the mass of anything are closely related. But you can look that up in Wikipedia or a science textbook or whatever. So when you talk about the amount of trash that you find anywhere, you could talk about the weight of it or the mass of it, or you could talk about the volume of it. In other words, how much space it takes up. Well, if you have a bag of something, if you have a bag filled with objects, there are a number of different ways in which you can find the volume of that. Now, I'm going to use this bag of bling as an example of how to find how much volume a bag of something takes up, because because this bling was sitting around the house handy, you know, and also because these are objects that are very small. They're able to manipulate and move around, and so you can easily put this bag into different types of shapes. Now, when you think about if you think about how to calculate the amount of space this bag takes up, there are a lot of different ways to do that. If you remember back in geometry class, you know, you learned how to calculate the area of different types of shapes, but also you learned how to calculate, if you remember right, you learned how to calculate the volume that different simple three-dimensional shapes will occupy as well. And one of the simplest shapes for which you can calculate easily the volume is a cube. And this is not a perfect cube. This little box is not a perfect cube, so I'll call it a rectangular prism, because it's a little bit taller than it is wide and deep, I guess you could say. So what's nice is that our bag of bling fits pretty nicely, pretty snugly into this square, or well, rectangular prism shape, and so if you so then we've got the bag is forced into a rectangular prism shape. Now you could actually hold it, I suppose, in your hands, you know, or have someone hold it in their hands in kind of a square shape and have someone else measure it, but that would be a bit more difficult. Using the box is easier. And so I'm going to measure this in inches, and the box is about 2.7 inches. Yeah, the box is about 2.7 inches by 2.7 inches. And then now the bag of bling does not totally fill up the box, so it's about 2.8 inches So, in other words, I measured this length and this length and then this length as well. So to get the three sides or the three dimensions. So 2.7 inches times 2.7 inches times 2.8 inches. So then if you have those three measurements, how do you figure out the volume of this bag that was forced into the shape of a square or a cube, roughly a cube, or a rectangular prism? Well, basically you just take, you multiply the depth times the width times the height. So 2.7 times 2.7 times 2.8 inches, and you'll come up with about 18.9 cubic inches. Now there are other ways in which you can estimate the volume as well, or measure the volume. For example, I've got this mug, and by the way, this is from Good Mythical Morning, the best channel on YouTube. It's your standard dink it and sink it mug. So from it's GMM, Good Mythical Morning, not a sponsor. But if you force the bag into the cylinder, so basically when we put the bag into this mug, we're forcing it into a cylinder shape, right? If you remember back to geometry class, it's pretty easy to calculate the area of the volume of a cylinder. Since it's been decades since I've been in geometry class, I had to look it up on Google. And according to Google, calculating the volume of a cylinder is done by taking pi and multiplying it by the radius squared take pi and multiply it by the radius squared, and then multiply it by the height of the cylinder. And so now it's really easy to measure the diameter of the round part of the cylinder, because the diameter is the distance all the way across, straight across. So the diameter is the diameter is 3.3 inches. Okay, so 3.3 inches then. So then you take half of 3.3 and you get 1.65. So 1.65 inches then roughly is the radius of this. And so you take the radius and you square it, and then you multiply it by pi, and then you multiply that by the height. Again, the bag of bling doesn't go all the way to the top of this mug, but it's roughly 3.3 inches, and so you get roughly 25.6 cubic inches, and 25.6 cubic inches is a little bit more than the figure that we got for the rectangular prism, which was 18.9 cubic inches. So these two measuring volume measurement methods don't exactly agree. Now, okay, so what other shape could you actually force this bag of bling into that would be a fairly simple geometric shape? Well, you get the sphere. You could put into a spherical shape, okay, and the spherical shape then now, so And the, well, okay, so now with this, we'll put it into the shape of a sphere. And if you measure the diameter, well, excuse me, the easiest thing to do, you can't really measure the diameter very much because the diameter is the distance that's straight across. The easiest thing to measure is actually the circumference, you know, how far around it is. And I've already measured the circumference going around this way is about 10.1 inches. But, you know, this isn't an exact perfect sphere. I'm not able to make a perfect sphere with this bag. So I'm going to get another estimate of the circumference of the sphere. So it's 10.8 inches. The circumference is 10.8 inches going around this way. So I'm also going to go around this way. And when I measured it before, going around the kind of vertically, I guess, on it, it was about 10.1 inches. So the circumference, the estimate of the circumference going around this way is 10.8, and going around this way is 10.1. So we'll just take an average of those, and that'll be the best estimate of the circumference of this sphere. And so the average between 10.1 and 10.8 is 10.45. So we use 10.45 as their circumference. Now, I put the formula for measuring the volume of a sphere into the comments for this video. And you'll notice that in order to actually calculate the area of a sphere, you actually need its radius, not its circumference. But the thing is, now that we have the circumference estimated at 10.45, we'll just plug that into a formula that'll give us the radius of the sphere. So in order to get the radius of a sphere, what you do is you take the circumference and you divide it by 2 times pi. So circumference of 10.45 inches divided by 2 times pi then will give you a radius of yeah, I forget what the radius was when we calculated it before, and I don't have it with me. I don't want to pause the video for it, but maybe I'll put the radius in the comments for the video. But anyway, so once you've got the radius, then you plug the radius into the area of a sphere equation, and you come up with an area of about 19.1 cubic inches. So when we had it into a cylinder shape, our estimate of the volume was 25.66 cubic inches, and when it was in the shape of a rectangular prism, our calculation was about 18.9 cubic inches, and when we had it in the shape of a sphere, our calculation was that the volume was about 19.1 cubic inches. So 3 different methods for estimating volume. Now the other thing is, if you remember right, I think Drew Norby actually mentioned on Monday, the first day of the camp, that you could also measure the area the volume of something using a method called water displacement. And so what we're going to do for water displacement is the easiest way to do water displacement is to actually fill up a graduated cylinder to whatever level with water and then put the object in it. Now I don't have a graduated cylinder here, but we can easily do this anyway. I've got a mug, and again, and this is a GMM mug, a Good Mythical Morning mug, so again, more merch from the Good Mythical Morning channel. But anyway, this mug is full up to the rim with water, and I've got the mug sitting in a larger plastic bowl, So what I'm going to do is I'm just going to force the bag of bling all the way into the mug. And it's important to get it all the way into the mug so that you're actually measuring all of its volume. So force that bag down in there all the way into the mug, and there you go. It's basically all the way into the mug. And so now, since water was up to the very rim of the mug, then immediately when I started pushing that bag of bling into the mug, it started pushing water out of the mug. So basically, and since I pushed the whole bag into the mug, then basically the amount of water that was forced out of the mug would be exactly equal to the amount of volume that the bag takes up. So that's the water displacement method. Now all we have to do, I hope there's no water inside the bling bag. Don't want a bag of wet bling sitting around. But anyway, so now we have a certain volume of water then that should be equal to the volume of the bling in the bag. And so now all we have to do is measure the amount of volume of this water, the amount of volume that we've displaced. And for that, we just need some sort of measuring cup. And I don't have it here with me, but just give me a second, I will go grab it. And I'm back. Okay. Now this one will measure things in cups and ounces and milliliters. But now you remember that, well, okay, it's fine to measure things in cups and ounces and milliliters, but we were actually measuring things in cubic inches. Well, don't worry, there's a formula for converting things from milliliters to cubic inches. So, but anyway, we've got our empty measuring cup, we've got the water that equals the volume of that bag of bling, and so now I will carefully pour the water from the bowl into the measuring cup, being careful not to spill any of the water onto the keyboard of my computer. Do not try this at home. And here we go. All right. Now, I don't know if you can see this or not. In fact, I might have trouble seeing it too. But anyway, the volume of water in this measuring cup is almost exactly 340 milliliters. 340 milliliters. Now, if you find the right equation for conversion, or if you Google it, you'll discover that 340 milliliters is equal to, in cubic inches, 20.748 cubic inches. And so 20.7, round it to 20.8. So 20.8 cubic inches is closest to the sphere shape that we did, and so I'm just assuming, we're just assuming that the water displacement method was the best method, the most accurate method for estimating the volume of that bag of bling. But if that's true, then the next best method was actually forcing it into the shape of a sphere. Now the thing is, with a bag of bling, it's fairly easy to force it into a simple, regular geometric shape, and do a pretty good calculation, pretty good estimate of its volume. But with a bag of trash, like what we've been talking about, because sustainability is one of the main themes of the camp. With a bag of trash, trash is going to be kind of irregularly shaped, and it won't really lend itself well to being forced into a regular geometric shape. But what we did last year when we looked at trash is we pushed it into a shape that was close enough, as close as possible to a sphere, and we just took we measured it around top to bottom and then side to side, and maybe a couple more times, and did a kind of an estimate, or excuse me, kind of an average of those diameters of the bag, in order to just get a rough estimate of the volume of that trash. We didn't have to be exact because it wasn't, exact research. We just wanted a pretty good estimate in order to have some figures to work with when we went into the rest of our math exercises that had to do with the volume of trash within the whole community. But anyway, so this is basically what we did then in the June 23rd bridge camp, summer 2020, when we discussed estimating the volume of bags of trash. So if you have any questions, feel free to contact me by email. Would be the best, I suppose. So that's it then, and thank you for watching, and have a great time during the rest of the camp. Thank you.